our goal is to start with y equals the absolute value of x, and I will draw that as our original graph. And we want to end we want to graph this entire graph. And the way the textbook wanted us to do it is to do it slowly. We're not going to do it slowly because it's going to take too much time. But the idea was, they say, okay, can you graph just with the two? That would make a horizontal compression by a half. And then add the vertical compression by a quarter. Then after you've done that, move it 3 to the left. Then after you've done that, move it 4 up. Okay? We're going to learn that we can do all of these all together. First of all, we're going to start by labeling. On the green graph, we are going to have a vertical compression. Y gets multiplied by 1/4, because that 1/4 is outside the absolute values, so it's vertical. Then we have a 2 inside the absolute values, so that will be a horizontal compression. You're going to multiply x. And everything inside is the opposite. One teacher once said that the x's are liars. The x's always lie to you. You see a 2? No, they're lying. They want you to multiply by half. You see a +3? The x's are lying. This is a horizontal translation, not 3 to the right, but 3 to the left. And this 4 is outside the function. That's going to move things 4 up. So you have a bunch of things to do. And you have points that you would start with. Personally, I'm going to, well, we're for sure going to have to use 0, 0, because that is the key point on an absolute value graph, because it's where it changes directions. Noticing what I have to do. I'm going to have to multiply my y's by a quarter. I need to multiply my x's by a half. I'm going to choose that point because the y values nicely divide by 4. And I'm going to choose this point over here on this side for that same reason. So I take a look at the transformations that are going to happen, and I do a little bit of mental math trying to pick nice points.
Better than the ugly points.
Better than the other points.
Can I have that?
Yeah, for sure. Can I give you one extra to scan through with it?
Sure.
And then what we're going to do is, first of all, make a note off to the side that's very important. Is that the order matters. Because we have two things that happen to y. We have to multiply our y's by a quarter, and we have to add 4 to them. And if you do them in the wrong order, you're going to get the wrong graph. Now the order is really easy. Okay? One way to think about the order is just like you read from left to right, we need to do the order from left to right. Okay? So this is a simple way of remembering the order. We would have to do the vertical compression and horizontal compression first, and then the translations last. So we'll make a note with that. stretches and compressions first. Translations last. So we do our stretches and compressions first, and our translations last. What that will look like in our method, we can start with our points. We have -4 and 4, 0 and 0, and 4 and 4. We're going to draw arrows. An arrow for our stretches and compression, and an arrow for our translations. So when we have multiple things happen, we will always do stretches and compressions. So this first part here is our stretches, and this part here is our translations. So above my arrow for my stretches, I can look, I have two of them. My x value is getting multiplied by 1/2. My y value is getting multiplied by 1/4. And for my translations, I'm going to go 3 to the left and 4 up. And it's kind of like order of operations as well. You always have to multiply before you add and subtract. So we have to do our multiplying, which is our stretches and compressions, first, and then we have to add and subtract second. And again, be very careful in your mental math as you're going here. So first of all, x by 1/2, that'll be -2. This will still be 0, and this will be 2. Y by 1/4, this will be +1, 0, and +1. As you do your mental math, do a quick double check that your numbers are right. It'll save you more time, because if you make a little tiny mistake, your graph looks completely different, and then you have to start all over again, because usually it's quicker to start all over again than it is to find your little mistake. And now finally we can get our final points, 3 to the left, so this will be -5, -3, and -1. And 4 up, this will be 5, 4, and 5. So on my graph, I would label -3, -3, 4, -1, 5, and -5, 5. And get my final graph. And with this idea, you can now graph just about everything. If you know what the original graph looked like to start with. So for this one, we knew what the original absolute value of x graph looked like. Now, any kind of numbers put inside of with an absolute value, we should be able to graph. Because we start with the points on our original graph that we know. We notice which kind of transformations have happened, find out where those points end up, and draw our final graph. So if we go to example 1, they would like us to sketch and label a graph with a vertical compression of 1/3 and a translation of 2 units up. So if we're doing the method with the points on our original graph, we have these 4 points. I can label them. I have -5, 3, -2, -3, 1, 0, and 4, 6. We do always our stretches first. In this case, we have a vertical compression by a factor of 1/3. That tells us verticals affecting our y values. Our y values are going to get multiplied by 1/3. And that's the only compression. Notice your x values, there's no horizontal stretches or compressions. So we only have one thing to do there. That's fairly easy. So my x values will not change. And my y values all get multiplied by 1/3 or divided by 3. And then we move to up. So now that is also only affecting my y values, so my x values are not changing. 2 up would be 3, +1, +2, +4. And we can label our new points -5, 3, -2, 1, 1, 2, and 4, 4. And the graph has been compressed by 1/3 and translated 2 units up. If we wanted to label this in terms of g, the 1/3 would be outside of g of x. The +2 would be outside of g of x. This is how we could label our equation in terms of g. I'm going to get you to circle questions 4, 5, and 6. But we are going to do the example that the textbook does as well, because there's something that is interesting that happens with this graph. Okay? So once again, we have these 4 points. I'm going to quickly list them here for you. -4, 3, 0, -2, 2, 5, and 4, 2. And everything else is basically the same in this question. There's just something right at the end that is an important note that I want to show you. So if we did everything the same, we read this question, it says horizontal compression by a factor of half. That tells us that our x value is getting multiplied by half. So x values are all going to change. Y values are going to stay the same. And then we're going 3 units to the left. Again, my x values change, -5, -3, -2, and -1. Y values don't change. So up till this point, everything else was the same as far as getting my new points and drawing my graphs. I did my stretches and compressions first, and then I did my translations second, and I graphed my new graph. Okay? The thing that is different in this one is students often make a mistake when writing the equation. Because when writing this equation, x by a half and 3 to the left, they think of two options. So I'm going to write both options for you here. And I want you to think about which option is correct and which one is wrong. I want you to think about what your gut would tell you to write. Because even if I show you the right answer, you will go with your gut on the test, even if you've seen the right answer. And if your gut tells you the wrong thing now, you will do that again on your test, unless you make a conscious decision to correct that mistake. So here are the two options. We want x by a half and 3 to the left. We are going to write the equation. It has to be inside the function. And these are our two options. Okay? One option, we have x by half. So first of all, we have to remember that we have to write 2x. And then we have 3 to the left. We have to remember that 3 to the left is plus. So those are our two options. One has a 2x plus 3, all inside of f. The other one has a 2x plus 3, but the x plus 3 is in its own brackets. One of these is right, and one of them is wrong. Okay? So right now, you have to ask yourself, what would you write? Would you write the top one, or would you write the second one if you were doing this question and were asked to write the equation? Okay? Because you want to know what your gut tells you, because you're going to go with your gut on what you think is right on a test. Now, this one is wrong. So if your gut went with that one, we need to make sure we correct it, and we're going to write a special note at the bottom of the page here. I almost want to make this a sad note, because every year, because of this special note, I probably take off 20 to 30 marks all year, because you're going to forget this over and over and over again. Here's a special note. When you have and this only happens with horizontal sum. When you have a horizontal, either stretch, compression, or reflection, any one of those, and a horizontal translation, the equation needs to be written in factored form. And in factored form means that that x plus 3, the 2 is factored out of it, and you have an extra set of brackets. If you think back to our very first thing that we did with the absolute value, notice in the absolute value question, it was in factored form. That 2 was outside, the x plus 3 was in brackets already. One year, I had a student say, I'm not going to forget this. I don't know how you exactly do this, but they set a reminder on their phone for like 9 p.m. every night. Their phone would buzz, and it would say, special note when you have horizontal. And every night they would read that, and they're like, okay, I won't forget that. Now, there's so many things that you have to remember for grade 12. If you start doing notes to yourself to remember, you might spend 3 hours every night with your phone going, and remember this, and remember this, and remember this. But this one in particular happens so much. I think I have at least 8 points you can lose on your first test if you don't remember this. Very easy to remember because this looks simpler, right? When you don't write it with the brackets. And we like to do things simpler. But in this case, it doesn't work out. So horizontal ones, we always have to write it in factored form.